Hello, welcome to a video on solving quadratic equations. So anytime we solve a quadratic equation, all that means is we're given some equation, and in this case, I chose the equation y equals 2x squared plus 5x plus 3, and we're trying to find where the graph of this function intercepts the x-axis. Okay, so if this is our function here, and this is the x-axis right there, we're trying to find which points the function crosses through the x-axis. Okay, so the first thing we have to ask ourselves is, well, if it crosses through the x-axis, we're looking for the x values. We have an equation with two variables, y and x. If we're trying to find x, that must mean that we know what y is. Because if we're going to be able to solve for x, our true variable, we have to know the other variable, y. Because if we have two variables and one equation, we can't solve anything. Okay, so if the function is crossing through, it's crossing through the x-axis at these 2 points, what's its y value going to be? Well, it's going to be 0 because you can think of this like, let's say you're graphing a function of you jumping in the air, right? If this is the ground, right, and you start on the ground, you jump up, gravity pulls you down, and you end on the ground, right? You can think of the ground as your x-axis. If your height is 0 meters off the ground, well then the roots of this function, if you were to graph it, would just be kind of the x coordinates of where you start. So like your initial x and your final x of where you start and where you land on the ground. Okay, so your y value, your height, the height of the function is just going to be 0. So if y equals 2x squared plus 5x plus 3, one conclusion we can make is we know that 0 equals 2x squared plus 5x plus 3. So now that we know this, we're going to be able to solve for x if there is a real solution for x. And there are a couple ways that we can go about doing this. We can use something called the quadratic formula. We can use a factoring method, and we can use something called completing the square. This video, I'm going to teach you how to solve quadratic equations by factoring. So it's kind of an introduction into what solving quadratic equations means. And we did all that work on factoring, and now we're going to actually put it to use. Remember, we had to do factoring by grouping and all this other stuff to get it into two brackets. What was that even for? Well, it's for this video right here. If we're trying to solve a quadratic equation and we don't have a calculator, we can't use a quadratic formula, how do we solve it? Okay, so we can only solve it if this right here is factorable with whole numbers, and it is factorable with whole numbers. So we can use the box method, we can use factoring by grouping, but we can also think about it just like in our heads, because this coefficient in front of the x squared is 2, so we know the first kind of the leading parts of the brackets are going to be 2x and x, right? Because those are going to have to add or multiply to 3x. Okay, and now we're just left with what we're adding or subtracting in each bracket. So we know that the last two numbers in each bracket has to multiply to 3. Whether there's a 2 in front of the x squared, a 10 in front of the x squared, or a 1 in front of the x squared. The last numbers in each bracket have to multiply to the constant in the equation. In this case, that's 3. So they can be negative, right? They could be -1 and -3. But if we add those together, we're not going to get a positive number like 5x. So even though +3 and +1 don't add to 5, right? They only add to 4. That's not the thinking that we should be doing, because there's a 2 in front of the x squared, and that kind of messes up our methods. So we're not even thinking about this 5 right now. All we're thinking about is that the factors of this +3, they have to both be positive because the numbers have to add to a positive number. So let's try doing +1, right, and +3. Those multiply to +3, right? So if we expanded this out, we would get 0 equals 2x squared, right? 2x times x plus this 1x, or this 1 times x, so plus x 2x times 3, so that's going to be plus 6x, and then 1 times 3, that's going to be plus 3. If we bring these two together, we're going to get 7x, and that's not what we had in our original equation. We had 5x. So that must mean that we have to switch the order of the 1 and the 3. Okay, we're going to switch the order of the 1 and the 3, so this is going to be 2x plus 3 and x plus 1. So now when we multiply this out, we're going to get 2x times x, which is 2x squared, 2x times 1, which is 2x, 3 times x, which is 3x, and 3 times 1, which is 3. So when we add 3x and 2x together, we're going to get 5x. So that's how we know we factored it correctly. Now, to actually solve for x, the hard part is done. We've done our factoring. All we have to think now is these two brackets, these two things, they're multiplying together to equal 0. We know that the other side equals 0. And we also know that if we multiply one thing by another thing, if either of those things are 0, then the product of those two things is going to be 0. And here's what I mean by that. If we have 50 and we multiply 50 by 0, we're going to get 0. If we have 0 and we multiply it by 172, we're going to get 0. Also, if we have 0 and we multiply that by 0, we're going to get 0. So anytime we have two brackets that are multiplying together and equal 0, either one of them equals 0 or both of them equal 0. So 0 times anything is 0, and 0 times 0 is 0. So that means if we have two brackets up here that we factored, and when they multiply together they equal 0, like it does here, we can set 2x plus 3 and x plus 1 equal to 0. Because if either of these equals 0, say this first bracket equals 0, but this first bracket equaled 500, it doesn't even matter what this bracket equals, because as long as this one is 0, 0 times the other bracket is still going to be 0, which is what we want. And similarly, let's say the one on the left was 500. So let's say we plugged in an x on the left bracket. We said that equaled 500. If this bracket was 0, 500 times 0 is also 0. So as long as either of the brackets are 0, that's going to be a solution to the quadratic equation. So to figure this out, we kind of blow this up into two parts. We get 2x plus 3 equals 0, right? That's this part there. And we also get x plus 1 equals 0. That's this part right here. Okay, so if 2x plus 3 equals 0, we can just solve for x by subtracting 3 and then dividing by 2. So we get x equals negative 3 over 2 or negative 1.5. Okay, and over here, we just have one thing to do. We just subtract 1 on each side, so those 1's cancel, and we get x equals negative 1. Okay, so these are our two solutions for our quadratic equation, and let's just zoom in here. Yeah, perfect. So we got negative 1.5, and we got negative 1. Okay, so if you plug in negative 1.5 or negative 1 for x into this equation, you should get 0. Okay, so let's just try that out. We got y equals 2x squared, right? We got y equals 2x squared plus 5x. Okay, and then it was plus 3, if I'm correct. Yep. So let's do the 1.5 first, negative 1.5. We know 1.5 is 3 over 2, so let's go 2 times 3 over 2 squared, and this is negative 3 over 2, plus 5 times negative 3 over 2, right, plus 3. So if we simplify the fractions here, negative 3 over 2 squared, that's positive 9 over 4. 2 times positive 9 over 4 is going to give us positive 9 over 2. So that's going to be positive 4.5. Okay, and then we're going to add 5 times negative 3 over 2. That's negative 15 over 2, which is going to be negative 7.5. So minus 7.5. And then we just got plus 3 here. If we did this in our head or put it into our calculator, right? 4.5 minus 7.5, that's negative 3. And then negative 3 plus that 3 on the end, that's going to equal 0. So y does in fact equal 0 when x is negative 1.5. Okay, so now let's try it with the negative 1, because that should also work. And if one of them doesn't work, then that solution isn't correct. Okay, so y equals 2 times negative 1, we're seeing if this is correct, plus 5 times negative 1 plus 3 equals 0. Let's see, well, negative 1 squared is going to be 1, right? Negative 1 times negative 1 is positive 1. So 2 times positive 1 is 2. We got 5 times negative 1. That's going to be negative 5. So 2 minus 5, and we got that plus 3. 2 minus 5 is negative 3 plus 3 is going to be 0. So this also works. Okay, so both of our solutions work. Let's see if we can do it a different way here. Let's try, how about one that looks like we got 4x squared minus 9 equals y. So that's our function. How could we find the x-intercepts of this one? Well, there's a couple ways we could do it. One way we could do it is we know that y is going to be 0, right? Anytime we're trying to solve the quadratic equation, we say that y is 0, so 4x squared minus 9 is 0. One way that we could do it is see that there's only an x in one of the terms. So that means if we add 9 on both sides, right, we'll get 4x squared equals 9. To just get x squared, we divide by 4 on both sides to get rid of that 4. So we get x squared is 9 over 4. And by square rooting both sides, we get rid of the x squared. And we have to add this plus or minus here. So x is going to be plus or minus the square root of 9 over 4, right? The square root of 9 over 4, that's like the square root of 9 divided by the square root of 4. So that's plus or minus 3 over 2. Okay, so this is the solution for this question right here. Another way we could do it is by factoring. Okay, so you might notice equals 0. You might notice that 4, x squared, and 9 are all perfect squares. And you might also notice that the 9 is being subtracted from the 4x squared. So that means we can use our knowledge of differences of squares. So how we factor it is we take the square root of the first term. So the square root of 4x squared, we take the square root of 4, which is 2, multiply it by the square root of x squared. Well, that's just x, right? Because x squared is just x squared. So going the other way, the square root of x squared is just x. That's going to start off both of our brackets. So just to make sure, 2x times 2x, yep, we're good. That does equal 4x squared. And then all we do is we take the square root of the second term, so 9, which is 3, right? Square root of 9 is 3. We just do a plus here and a minus here. So when we expand this out, we're not going to get any x terms, just x squareds and constants. Okay, and just like we did in the last one, we're going to set each bracket equal to 0. So either the bracket on the left, 2x plus 3 equals 0, the bracket on the right equals 3, or the bracket on the right equals 0, so 2x minus 3 equals 0, or both of them do. So maybe both of them equal 0, because 0 times 0 does equal 0. Okay, so for this one, we just subtract 3, and then divide by 2, so x is negative 3 over 2. And then for this one, we add 3, so 2x equals 3. Then we divide 2 once again. So this is negative 3 over 2, this is positive 3 over 2. And notice how for this solution here, we just said plus or minus 3 over 2. So that's the same answer. Both of them work. Both of them are equally valid. It's just depending on if you like factoring differences of squares or you like to solve it more algebraically by just square rooting both sides. I'm doing some algebraic manipulation there. Okay, let's do one more. Let's do f of x equals x squared, and then we'll go we'll go minus 11x plus 30. Okay, so what we have to do now is we have to factor this, right? Because we can't do our difference of squares trick because we have an x term here. So we have to set f of x, which is just our y, equal to 0. And then we have to factor it into two brackets. So this one starts with x, so this one starts with x, right? X times x is x squared, which is what we want. And then we have to think of two numbers that multiply to positive 30 and add to negative 11. Okay, so if you break that down, the answer we want, it's going to be negative 6 and negative 5. Because both of those add to negative 11 and multiply to positive 30. Because negative 6 times negative 5 is positive 30. Okay, so it's going to be x minus 6, x minus 5. If we multiply these together, we're going to get our original function back. And we're also saying if we multiply them together, we should get 0 because our function value is 0 when we're looking for the x-intercepts. Okay, so just like the other two questions, we set both brackets equal to 0 because either one of them equals 0 or both of them do. So x equals 6, x equals 5, right? Just adding 6 and adding 5 on both sides. So if you were to graph this function, it would cross through the x-axis at x equals 6 and x equals 5. Okay, I hope that video was helpful just on solving quadratic equations by factoring. And like I said, there's lots of different methods that we can use. We can use completing the square, right? We can use the quadratic formula. We can use just our own algebraic knowledge of solving quadratic equations. But we like to use this method if we don't have a calculator and we're doing it on a test and we have an equation that is in fact factorable. Okay, so I'm going to be talking lots about different methods of factoring, but this is just kind of an introduction into like what solving quadratic equations actually is, what the roots are, right? Roots are just another word for the x-intercepts, right? And what solving a quadratic equation even means. So I'll see you in the next video, and I hope this was helpful.